Hello dear students, very good morning to you all. In today's class we discuss one more very simple and most important topic named computer generations from module number 1. You may get a question on this topic in first internal or in VTU main examination. The question will be like this: discuss in brief about computer generations. They may ask for 5 marks or more marks also. There are totally 5 generations are there. First generation of computers, second generation of computers, third, fourth and fifth. If you explain each, you may get 1 marks for the quality points with some examples you need to give for all the generations. If you do so, you get very good marks in examination. In today's lecture video, first I explain you about the first generation of computers with quality points and their features we discuss. Then we look at the examples for first generation of computers, ENIAC, DVAC and UNIVAC. Afterwards we discuss about the second generation of computers, quality points and their features, and we look at some examples. Then we discuss about the third generation of computers with their features and examples, and fourth generation of computers with their features and examples. Then the fifth generation of computers with features and examples. At the end, as a consolidated, I explain you computer generations. You can remember this entire table and you can write this in the form of table also the answer. At what time you are able to remember all these points is that if you listen to my explanation, definitely you remember all these points, definitely you are able to recall and write in examination, so that you can get good marks in examination. That is what I teach in my today's class in this lecture video. Let us begin with what are computer generations. What are computer generations, do you know? Yeah, all of you are intelligent. Computer generations means what? In olden days we were using the computers whichever we were using in olden days, their size was very huge, large in size. See, you can see the olden days computers. These are the first generation of computers. You can see the size of these computers. They occupied the entire room. But today's computers are very small in size, very portable. Even smartphone is also one computers for us. Okay, the size has been reduced, speed is increased, storage size is increased. Means we saw a lot of changes. We saw a lot of changes in hardware technology and software technology. Then what do you mean by computer generations? Generation of computers means change in hardware technology and software technology, used for processing the given input to get the desired result by using that computer system. That is what we call it as computer generations. There are totally 5 computer generations known till date. First generation of computers, you need to memorize the year 1946 to 1959. We were working with first generation of computers, and the major processing unit used within first generation of computer was vacuum tube. In today's machines we are using processors like ULSI processor and VLSI. i3, i7, i5 processors will be having these integrated circuits. But in olden days, in first generation of computers, vacuum tube was processing unit. In second generation, transistor. In third generation, ICs, integrated circuits. In fourth generation, VLSI, very large scale integrated circuits were there as a microprocessor. In fifth generation, ULSI, ultra large scale integrated processors we started. Now we are in the fifth generation. You need to by heart, you need to memorize the years 46 to 59 first generation, 59 to 65 second, 65 to 71 third, 71 to 80 and 80 onwards fifth generation. Let us start our discussion with the first generation of computers. The period for first generation was 1946 to 1959. And vacuum tube, you can see the image of vacuum tube. This was the processing unit within first generation of computers. This processor itself was large in size and it was generating a lot of heat also. This vacuum tube was similar to the electrical bulb. It was producing a lot of heat, so there was a need of AC for the first generation of computers. And the operating system whichever we used with the first generation computer was batch processing operating system. We were giving the inputs to a computer system by using the punched cards. Okay, this is what the punched card we say. You can see this punched card. Here you can see some numbers also. With help of punching machine, we need to punch on this card. We need to learn about that one. You can see this might be the Fortran program, Fortran statement. Here somewhere they punched it, and they were giving inputs to the first generation of computers by using the punched cards like this. Okay, punched card was similar to in olden days in KSRTC bus. Conductor used to give the paper tickets and he used to punch the tickets according to our source and destiny place. Similar to that kind of input card we are using. In the form of batches we were giving the input to computer system. That's why in first generation of computers batch processing operating system was used. Punch cards were used to give input to a machine, and to store the output magnetic tape was used. And what are the features of first generation? Huge in size, very expensive, and we are using machine language to give the instructions. We were giving the instructions to computers in zeros and ones only. It was very tedious job for the programmer. Today we are giving the instructions in high level language. In C language we are writing the program today. It is very easy to write the programs in C language. It was very tedious job to write the program in machine level language. And first generation of computers generating lot of heat, so need of air conditioner, consuming lot of electricity. And there are three examples, even more are there. ENIAC, EDVAC and UNIVAC. Electronic numerical integrator and calculator was the first electronic computer. EDVAC, drawbacks of ENIAC removed in EDVAC. Electronic discrete variable automatic computer. Drawbacks of EDVAC removed in UNIVAC. Universal automatic computer 1. And I explained a little bit about the ENIAC. No need to write about these things in examination. Just for knowledge I am explaining to you. You can see the image of ENIAC machines. Oh, very large in size. Oh, first electronic computer developed by American scientists John Presper and John W. Mauchly in 1946 by using semiconductors. It had short memory. Very less memory was there. Various components had to be manually operated in different ways to perform different calculations. Its size was 80 feet long and weight was 30 ton. Oh my god. It was used by American government to calculate the paths, trajectories of bombs and shells. This machine could be reset to perform other types of calculations by changing switch settings and plugs and socket connections. You can see the programmers are changing some sockets and they are changing the plugs. They are modifying the program in machine language. The biggest problem with this computer was that all the instructions were hardwired within the computer. Like this you need to instruct to a computer system. Very tedious job. This is what all about the first generation of computers. And EDVAC was the one more example. Is one more example for first generation. Introduced by John O. Newman in 1950 with a new feature, storage information in large internal memory. Memory is increased, and to overcome the drawback of ENIAC. In ENIAC, large internal memory was not there. It was introduced in EDVAC. It was capable to read data and instructions. Oh, and from external resources through the punched cards. Thus, problem of ENIVAC was solved by it. Oh, we were giving the inputs by using the punched cards within EDVAC. Oh, UNIVAC, Universal Automatic Computer, was developed in 1951. It was developed for both scientific calculations and commercial calculations. So, it also had compiler to translate program to machine code. Oh, translator was introduced in UNIVAC. These are the diagrams of vacuum tubes. These are the diagrams of vacuum tubes. You can see the vacuum tubes here, and these are all the examples for first generation of computers. If possible, you can draw the diagram of punched card in 2D diagram like this: glass envelope, plate, anode, filament, cathode. You can draw the diagram like this also if you have the time. Just explain few points, features and examples. That's all. No need to explain all these things. Okay, very good. This is what all about the first generation of computers. Next, second generation, and 1959 to 1965. In this generation, transistors were used. You can see the image of transistors. Actually, these were very cheaper and consumed less power, more compact in size, more reliable and faster than the first generation machines made of vacuum tubes. Oh, very good. One transistor was equivalent to nearly 40 vacuum tubes. The working of 40 vacuum tubes did by only one transistor. In this generation, magnetic cores were used as the primary memory and the magnetic tape and magnetic disk as secondary memory. In this generation, assembly level language was used to write computer programs. Oh, assembly level language means abbreviations we are using: ADD for addition, SUB for subtraction, MUL is for multiplications, instead of remembering zeros and ones combination. In first generations, for addition you have to remember the combinations of zeros and ones, but in second generation, ADD word you need to remember. It is easy to write the programs in assembly level language in comparison with machine level language, but there is a need of assembler that converts the program from assembly level language to machine level language. Okay, no problem. Features: use of transistors, reliable in comparison with the first generation, smaller in size in comparison with first generation, generates less heat in comparison with first, consumed less electricity in comparison with first, faster than the first, and it was also very costly, AC required, supported machine, and assembly level language was used. Examples: International Business Machine 1620 version, CDC 1604, UNIVAC 1108. This is what all about the second generation. Next, third generation, very interesting. Here because of Jack Kilby, third generation computers we saw. Jack Kilby was American electrical engineer who took part in the realization of the first integrated circuit. He invented integrated circuits while working at Texas Instruments in 1958. He was awarded the Nobel Prize in Physics on December 10, 2000. Okay, in the period of third generation, 1965 to 1971, the computers of third generation used integrated circuits in place of transistors. Transistors were replaced by ICs. A single IC has many transistors, resistors and capacitors inside along with the associated circuit. The IC was invented by Jack Kilby. This development made computers smaller in size, reliable and efficient. One IC is equivalent to nearly 10 to 100 transistors and even more. Oh, interesting. In this generation, remote processing, time sharing and multi-programming operating systems were used. Operating systems were changed because of ICs. High-level languages. We started to write the programs in English language, and compiler we used to convert it from high-level language to machine-level language. Formula translation, common business-oriented language, Pascal, PL1, basic beginners all-purpose symbolic instruction code, algorithmic language 68, etc. were used during this generation. Features: IC used more reliable in comparison to previous two generations, smaller in size, generated less heat, faster, less maintenance, costlier, AC required, consumed less electricity, supported high-level language. You can see because of Jack Kilby, because of ICs, size of the electronic goods reduced. You can see in front of Jack Kilby, you can see the n number of electronic goods sizes were reduced because of the invention of ICs. Oh, nice. Okay, we need to be very grateful to Jack Kilby. Okay, thank you. This is what all about the third. Next one is fourth generation computers, 71 to 1980. Very large scale integrated circuits were introduced. VLSI, having about 5000 transistors and other circuit elements with their associated circuits on single chip. One LSI, large scale integrated, is equivalent to 100 to 1000 transistors. One VLSI, millions of transistors. These machines were more powerful, compact, reliable and affordable, and it gave rise to personal computers. Then personal computers were introduced so that we can purchase our own computer to do our calculations. In this generation, time sharing operating system, real-time network operating systems, distributed operating systems were introduced. All the high-level languages like C language, C++, COBOL, Fortran and many more we started to use with the fourth generation. VLSI technology, very cheap, portable and reliable. Use of PCs, very small size, pipeline processing, no AC required. Concept of internet was introduced. Oh, interesting. Great developments in the field of networks also. Examples: DEC 10, star 1000, PDP 11. Supercomputers were introduced, Cray 1, Cray X, MP, supercomputers. You can see the images of supercomputers. These are all supercomputers. And you can see here Cray supercomputer. Param is the supercomputers designed and developed by Indians. Okay. Dr. Vijay Pandurang Bhaskar is the architect of supercomputing in India. He ruled out India's first supercomputer, Param 8000. We can see different versions also here. It was the second fastest supercomputer in the world in the year of 2015. He was honored with Padma Bhushan for his invaluable contribution. Feel proud to share this picture. Okay, thank you. Quality of Param 1000. This is a different version. Param 10000 supercomputer capable of performing 1 trillion mathematical calculations per second. It was based on open frame architectures. Is 100 times more powerful than the first Param machine built. This is what such machines were introduced because of 4th generation of computers. Now we are in the 5th generation. The period of 5th generation 1982 till date, ULSI, ultra large scale integrated circuits we are using today. It is having 10 million electronic components. This generation is based on parallel processing hardware and artificial intelligence software. AI is an emerging branch in computer science which interprets the means and method of making computers to think like human beings. It is possible because of such machines. All the high-level languages like C, C++, Java, .NET and many more. And ULSI technology, development up to artificial intelligence, development of natural language processing, advanced in parallel processing. Today our mobiles are quad core, octa core, means 4 processors will be there, 8 processors will be there. Each processor is having different tasks. Graphics processor deals with graphics calculations, and sound card processors deals with the sounds. Like that, n number of processors will be there in mobile itself today, because of which parallelly n number of programs we are able to run, because of we feel our laptop or mobile is working with high speed. That is all about the parallel processing. Parallel you can do n number of tasks. Such things are possible because of ULSI. And advancement in superconductor technology, more user-friendly interfaces with multimedia features, availability of very powerful and compact computers at cheaper rates we are getting it. You can see the desktop machines and laptop machines and the notebook machine, and this is the Ultrabook, this is the Chromebook. You can see desktop, laptop, notebook and Ultrabook and the Chromebook. And nowadays we are working with such machines. Oh, this is what all about the computer generations. And I think you can write like this in examination, or up to now whatever I explained you I covered in this table. You can write in the form of table also in the examination. First generation, second generation, third and fourth and fifth generation. Write the years here: 46 to 59, 59 to 65, 65 to 71, 71 to 80, 1980 onwards. Afterwards, processing hardware component: vacuum tube, transistor and IC, VLSI and DVLSI. You can make abbreviation and remember VT, VTI, not VTU, VTI. Then VU. Oh, you can remember VTU here, VTU. Okay. In between, before U, university, I and V, IV, 4. Okay. You remember the word VTU, and before university, remember the word number, Roman number 4. Okay. What V stands for? VTU, vacuum tube. T stands for what? Transistor. And last one is U, VLSI. Before that, IV, integrated circuit and VLSI. You can remember like this. And machine language and assembly and high level and high level. And you can write the features in your own way, no problem at all. Use size, very expensive, machine language, lot of it, and AC required, smaller size. Once you write the first one, you just go on improving the features. Okay. Evaluators will read it, but once you write quality points, they will not read the entire answer. You may get good marks. Okay, no need to worry about that. But always we need to write the truth, reality in examination on paper. Give examples: ENIC, EDVAC, UNIVAC, EEV, IICCU, IHPDP, ID. You can make some abbreviations and remember: DC, 10 star, PDP11, CRE1, CRE-XMP, desktop, laptop, and so. Thank you. I hope I explained the things with high speed so that you can watch the video. Everyone wants to learn many things in less time. Okay. If you understood, that is well and good. If not, please watch the video once again. Don't forget to write the comments. That helps me to improve my teaching skills. I hope I tried my level best to teach you. Don't forget to write the comments. Give some suggestions. Frankly, I'll be very happier person. Thank you. Thank you one and all. And take care. That is most important. Have a nice day. Thank you.